number 6. First off, you need to determine what type of series that is. How can you tell just by looking at it what type of series or sequence it is?
Arithmetic.
It's arithmetic. How do you know? It doesn't look like I'm adding something because it looks like mx plus b. Remember, you're looking to see if it's linear, right? As long as there's no exponents, no crazy stuff, that's a linear sequence. That would make it arithmetic. And since it's arithmetic, I get to use a formula, which is right up there. So we need to know the number of terms, and that's probably what got most of you. Number of terms. See that 12 up top? There's not 12 terms. Because we're starting at 0, I plug in 0 to start with, and going to 12, that's 13 terms. So you can always do top minus bottom plus 1 if you want to find the number of terms. Okay, 1 to 12 would be 12, 0 to 12 is 13. Yeah. But if you do 10 minus 1 plus 1, it does give you 10. Yeah. If you're starting at 1, then the top number is the number of terms. If you're starting at 0, it's not anymore. So 13 terms divided by 2. Now we need to know the first term. How do you determine the first term in the sum? You plug in the bottom. The bottom is 0. Plug in 0. What happens when you plug in 0? You get 2. How do you find the 13th term in the series? You plug in the top, which in this case is 12. What's 4 times 12, or negative 4 times 12 plus 2? Negative 46. And that's what you're going to do to find your sum. So it's 6.5 times negative 44, which was what?
Negative 286.
Negative 286. Okay, so be careful with your n. It's not just the top number, it's top minus bottom plus 1. Okay? Okay, so for number 13, what are you going to do first? We want to find D. We need to know how this sequence is being built. How can we find D? What does D represent? It's a common difference. What did we also call that? Their slope. Think of these as two-ordered pairs. I have 814 and I have 1556. Could you find the slope between those 2 points?
Yes.
Yeah. Subtract the y's. So find the difference in the terms. And then subtract the x's, which is the difference in the term number. That should tell me how much I've added to get from one term to the next. What's 56 minus 14? Okay, let's try that again. 56 minus 14. 42. 15 minus 8. So difference is 6. Now, do I need to go backwards and find A1 so that I can find A0 and write my expression? I don't really want to. Let's build on what we have. If I'm trying to, If I'm trying to get to the 24th term, and I have the 15th term, how many times would I have to add on my difference?
9.
12.
If I'm going from 15 to 24,
9.
there's a difference of 9 there, so I would have to add on 9 differences. Okay? So I'm going to say that A24 is A15, which is 56, plus 9 differences, which we just found was 6. And that should give me the 24th term. So 56 plus 54 makes 110. Okay? So there's the arithmetic. You're finding D, basically just finding a slope, and then building on one of the terms you already know.
Wait, where did that 9 come from?
Because we said that these two terms, the one I'm trying to find and one that I already have, are 9 apart.
Yeah, why did you write that?
Why did I write that?
That you just write A124.
Couldn't I just write A24? What else?
Instead of that 9 under the arrow. Oh, that's not part of the business.
No, that was just telling me that they're 9 apart. Sorry. Yeah, so that just tells me what number to fill in right there. Okay. Okay, let's do geometric. Now geometric, we're not finding D anymore. We're trying to find R, guys. So it's the same idea, but we have to do different operations because geometric is different, right? Instead of subtracting the terms, we're going to divide them. So 40.5 divided by 8. Now, how many times have I multiplied to get from the 7th term to the 11th term? We've multiplied 4 times. So this quotient shows a multiplication 4 times. R to the 4th. Okay? So find the quotient of your terms, and this is the difference of 11 minus 7. The two terms we have. Does anybody know 40.5 divided by 8? 5.0625. So that is R to the 4th. So then we want to do a 4th root. What's R? 1.5. Although technically it could be plus or minus 1.5.
We don't care.
We don't care?
No.
We should always care.
Why would it? No, it can't be because it's going on.
I'm taking the 4th root.
Yeah,
But for all I know, it's going positive, negative, positive, negative, positive, negative. Right? And we just got both positive terms. But would it matter if I'm finding the 17th?
yeah.
I mean, if the 7th, if an odd is positive, isn't every odd going to be positive? So it doesn't matter? No. Okay. If it was the 18th, it would matter. I could have 2 possible answers, right, Yummy? Ooh, I might need to change my test now. Okay, so I want to find the 17th term. Again, let's build on one we already have. I know the 11th term. How many times would I have to multiply by R to get from the 7th or the 11th to the 17th? 6. So I'm going to put a 6 up here to show how many times I would need R. Okay? So now let's plug in what we know. A11 was 40.5. R was 1.5. And then I've got a 6th degree. So when you type that in, I got 461.32.
Wait a minute. Why is 8 to the 11? I thought you were supposed to be the first.
But I don't know A to the first. And I don't want to have to go back and find it. So we could, but I'm just going to take some term I know and build on it. If I'm trying to go from 11 to 17, they're 6 apart. So I would need to use R 6 times. And then we can just plug in those 2 values. Okay? I have another page of practice problems for you today. You'll see more of those on there. Because I think most of you need to try those again.
Or you know what we should do?
What should we do, Alyssa?
Alright, here's the game plan. Alright, so today we finished going over this. Tomorrow we go over our other sheet. And then Monday we
Start a new chapter.
practice problems. And then Tuesday take the test.
Oh,
Or take home test every week.
sorry.
Take home test every week.
Oh, for number 18, it asks you to find the 11th term in the expansion. Remember, 11 is not going to show up in your answer. We're going to take that, take that number, subtract 1 from it, Jake. That tells me one of the exponents in my problem. This happens to be the second exponent.
I didn't know that's the second.
Well, if you look at the pattern, like the second exponent here is 0, but it's the first term. The second exponent here is 1, but it's the second term. The second exponent is 2, but it's the third term. Yeah. So if you subtract 1, that tells you your second exponent. So once I know the second exponent, I can build this term kind of backwards. I know y is to the 10th. There's my second exponent, guys. Now if y is to the 10th, what's the power on the x going to be? How do we know it's 4? Because we need a total of 14, and 10 plus 4 is 14. That can lead me to my combination, right? What's on top? 14. What's on bottom? Either 10 or 4. Does not matter because of the symmetry in Pascal's triangle. I'm going to use 4 just because it's less keystrokes. You know, everything counts, right? So, when we type this in, I'm going to do 14, math, left, 3, 4. There's my 14C4. And then times 4 to the 4th.
Can we use our triangle?
The 10th is only on the y, and since the y didn't have a coefficient, we don't have to worry about it. So, I lost it. My answer is 256,256.
Why did you multiply 10 to 44?
Because we need to combine all of the coefficients into one final one. If the y had something on it, I would have to multiply it also. Okay? Lydia, is that good?